So today is February the 12th, and I'm just going to start with math workshops. I've had so many kids who've been out and stuff, just to try to keep everybody caught up. Okay, now, like I've been saying with math workshop, we're going to talk about them, but that doesn't exactly mean that we're going to get exact answers. Please look at the first one, number 3 for today. I'm going to point out some stuff that totally you should be able to get this. Here we go. So they're saying that Nancy has 53 marbles. She buys X marbles to increase her collection. What does it mean to increase something? To add to it, right. So right there we know that we are only dealing with two answers. Which equation can be used to find the number of marbles that Nancy bought, and what is that number? So, don't say it out loud. Listen, I'm going to give you a chance, because I think this one's kind of easy once you think about it. What makes sense to go where the X is to get 105? Okay, so I'm going to let you fill it in. Does that make sense so far? Okay. I'm just like, we got to think some. Some of y'all are waiting on me to just give you an answer, and we got to kind of think about it. If you took these numbers and you put it with which one, would it work? Easy as that. Okay. On the second one, on number 4, there are 4 numbers you're working with. 7, 8, 15, and 23. Basically, you need to figure out, if you fill these in over here where X is, what makes sense, and pick an answer. Okay. Now, when you get done with that, will you get out last night's homework? And on last night's homework, I am not exactly taking a grade, only because it was yes, I've taught a lot today. If you're looking at me flip these papers. Okay, now, last night's homework. I am not officially giving a grade today because it's kind of like the first day we've done this. Tomorrow I will be way more picky. Here's the deal, okay? And I said this yesterday, but some of you weren't here, so I'm just going to kind of restate it, okay? This is the only box that I'm officially looking for. Oh, not that one, sorry. This one. That I am looking for the exact same number that I am getting. The reason is, the rest of them some kids need, and the rest of them some kids don't need, because they can make these jumps keeping an equivalent ratio all the way across. So what I'm saying is this, like on these, you might have something in that middle box. This kid might have 2 filled up. You might not even need those boxes. If you don't need them, you can leave them blank. Okay? Everybody good so far? Okay. So what we're doing, start with number 5 here. This is kind of what we did. We are trying to get basically equivalent ratios. So, if it takes, 2 pounds of apples to make 5 pies. They're wanting to know, what would you do if you had to make 20 pies? Okay, what kind of 4? Times. And this was easy, because if we just kind of block that off and we think of how to get from a 5 to a 20 using multiply or divide only, okay? Don't add or subtract. Only multiply, divide. Then in my head, this is what we're doing. Times 4 and then times 4. Everybody good so far? Okay. On the next one. So we're trying to get the students basically from 7 to 28. Well, can we jump from a 7 to a 28? What multiplication table? Times 4. Times 4. Okay, so if I use times 4 and I go to that box, I want you to use times 4 here and go to that box. Okay, don't stick it back here or anything. Better yet, go right over there in front of that air conditioner. Like, grab the binder. There you go. Okay. Does that make sense right there, where I did the times 4? Uh-huh. Okay. Did you kind of skip count by 7s and 2s? 1, 2, 3, 4? Yes, and you can do that. My friends who are absent, listen. She is just as right as I am, as long as she's got a 4. So she could have done this. She said, well, I know 2 would be 14. 3 would be 21. So 4 would be 28. That's fine. That is totally fine. Okay? Good so far? Uh-huh. Yeah, if it'll go into 28. The problems could be this. In a few minutes, they're not going to go into 28. Like, it's not going to be an even number. We'll get there in a minute. Okay. On the next one. It takes $270 to make 3,000 pesos. Now, to get to, basically to pull this 3,000 down to 100, divided by, I think you're on the wrong problem. Check this one. 10? Okay. 10 would work. 30 would work. Okay. Here's the thing. Yeah, I figured you were. Listen. If you do 10, you can get, like if you divide this by 10, you would get 27, and then here you would get 300. Then you could do by 3, and either way, like even if you go straight there with 30, it is a 9 in that box. 300 divided by 3 is 100. 27 divided by 3 is 9. Yes. You can. You can think of it, because we know that those zeros, both being on the end, you can get rid of them. 1 0. Okay, if you do 30, all it is if you do 30, if you divide by 30, you are going straight to that number. That is fine. So you do 270 divided by 30, and you get 9. Some kids need this box. They didn't see divided by 30. Stop saying that. You have this out. Everybody's got this out. Okay. Look at the next one. If you were trying to go from a 200 to a 25, I'm hoping that we kind of see this as money. Like this is $2. These are 25 cents. These are quarters. How many quarters would be in a dollar? 4. Thank you. You got it. So, divided by 8 would give me that. So, 48 divided by 8 is 6. Now, it doesn't matter. Someone else might have simplified it by 2 and 2 and 2 and 2. It doesn't matter as long as we all get the 6 right there. Does that make sense? Okay. As long as you got that 6, it does not matter what we have in between. You did what? What'd you divide by? Okay. It doesn't matter, but I mean, you kind of should know. Okay. Looking at the next one. This is where it's a little different. If you've not been paying attention, please look. Please stop. Put your calculator down. Okay. So this is one that we cannot get from an 8 to a 6 easily. There is no multiplication table or division table that jumps you straight from 8 to 6. So you are probably, what I call, going to need to simplify first. Let's divide. Let's think about this. 4 and 8 simplify by what? 2. Okay, so if I divide by 2, I get 2 on top, I get 4 on bottom. Can I jump from a 4 to a 6?
Yes.
4 to 6?
Yes, you can.
There's 4 times something is 6.
Oh, no.
Okay, so I need to do what with 2 and 4? Simplify, divide. I need to change it to 1 over 2. Now 2 times what is 6? 3. 1 times 3 is 3. See, there's reasons. Like, in Carson, what'd you do? I mean, Canada, what'd you do? Yeah, like that's what I'm saying. Someone might have seen 4/8 as 1/2, which is 3/6. I had one kid who did this, and I wish you'd look. One kid I had earlier saw that the 8 and the 6 kind of had 24 in common. So, they took the 8, they went up to a 24. So how do you get from an 8 to a 24? Times 3. Times 3. 4 times 3 is 12. Then they went from the 24 to a 6. 24 divided by 4 is 6. 12 divided by 4 is 3. Not really. It's called just finding facts, okay? It is finding those common numbers. That's the weird thing about this. The way you did it might be right, but you just did it differently. Okay? On the next one, I got 16 and 12. And my 16's with an 80. So what do you think we should do? Divide by what?
Divided by 16 to 80.
Okay, we could find unit rate, but I think that's going to be too hard.
So like,
think about it. What numbers do 16s and 12s have in common? 2s? Okay. Can I simplify this by 2?
yeah.
If you continue to talk and interrupt, please stop. So, let's say the only thing you see is a 2. So you say 16 divided by 2 is 8. You see 80 divided by 2 is 40. Okay. But you're like, once again, you're like, man, I can't get from an 8 to a 12. It's okay, though. We can still simplify this by...
4.
You could do 4. You could do 2. Either one. If I do 4, I get 2 and 10. But look, it doesn't matter. Can I get from 2 to 6? I mean 2 to 12.
Yes.
Times 6. What is 10 times 6? 60. But listen, sometimes you're going to have to bring the number down and then multiply in the end. Yes.
What I did is I divided 16 to 12, and it got 1.3 repeated. So then I divided 80 with 1.3 repeated, and it got 6.
Nice. We're going to be doing some of that today. Because what you were finding was like a unit rate. How much is 1? Okay. We're going to be doing some of that in just a minute. Okay. On the last one. It says we've got miles to days. You should have some words. And it's 190 miles in 4 days. Okay. Now I am changing it to 6 days. Once again, it does not matter what is in the middle boxes. You might use them, you might not. I have to, because I can't get from a 4 to a 6. Okay? I personally am thinking, if I can get that thing down to a 2, I can get it back to a 6. Does that make sense? Divide by 2? Okay, so if I divide this by 2, I get a 2. If I divide 190 by 2, don't guess at it, 95. Okay. Now, I can think 2 times 3 is 6. So 95 times 3, 285. Okay? Listen. 285. Okay? So sometimes, like, to me there's 3 ways you can do this. The first way is just easy, like simple multiplication tables that just happen to land on that number. Maybe even division tables that land on that number. The second way to me is simplifying. But if you're simplifying, a lot of times you may have to multiply in the end to get a bigger number. Okay? The last way is using unit rate. And that's what we're going to work on today. Unit rate is where the numbers may not come out very clean and crystal clear. They might be long decimals. So I need you to get with it. Okay? Now, if you are in here from another class, I do mine a drop different. Today, I'm using ratio tables, like yesterday. I know Sawyer was not using them earlier, and I don't know what Willis is doing today. So, you know, your answers can still be the same. I'm just doing it a little different. So, if you're in here and you're listening, that's all. What we're going to do is we're going to find a unit rate. How much is 1 before we can ever multiply? I was trying to think of how to put this. Okay. Now, basically, these are what I would call word problems because they're words. But I'm going to change them into the ratio tables because I think once we set those up, you all get it a little bit easier. Okay? go. Now, these are the notes for the 12th. Okay. What I'm going to do is change them to a ratio table. The first thing we may want to do on some of these, we may want to figure out what is 1. So what do they want 1 of? Like last week's test. Okay, here we go. So the first one is about pets. Out of 30 students surveyed, 17 have a dog. Based on these results, how many of the 300 students in the school have a dog? So basically they're comparing kids with a dog compared to kids without a dog. Okay? But I need you to think about it as this. We're trying to figure out how many pets each what has? Student. So student has to be on bottom. Student, like total students. So basically on top, I'm going to put students with dogs. And on the bottom, I'm going to call it total students. Well, these aren't the ones without a dog. This is like total. Okay. Give me a second. Wiggling around here. Okay, so looking up in my sentences or whatever, it says 30 out of 30 surveyed, so 30 total, 17 have a dog. So how many of the 300 students, so let's say their enrollment jumped to 300. Okay. Why times 10? Like, how did you jump on it so quick? Y'all say it.
30 times 10 equals 300.
Yes, because you know those, what I call fast skills. Okay, you know that to get from here to here, it is times 10. Does everybody agree? So 17 times 10 is?
170.
170.
Yep. I do that.
Okay. Now, I skipped the middle box. I could have brought it down to 15. I could have brought it down to 5. Okay, but I'm going to start getting some decimal numbers. Okay, yes. Yeah, yeah. That's what happens, yes. Uh-huh.
So, isn't the middle box more work? That's more work.
It kind of creates more work, yeah, but sometimes now you're going to need it. You're going to have to use it.
So,
Here we go.
you can do without the
If you can do it without, I say do it without. But you're going to see now it's going to happen. Okay. On number 2, we got lockers. If 1 out of 12 students at a school share a locker, how many share a locker in a school of 456 students? So, on the top, I'm going to put students that share locker. Compared to total students in school. You've got to have some words to describe those numbers. Okay, now I'm going to pull the numbers out of the words. It says if 1 out of 12 share a locker, that means 1 shares a locker out of 12, like it's a 1 to 12 ratio. So what if the school changed from 12 students to 456 students? Stop with the crazy comments. Just listen. Now, the thing is this. Some of you can get this without using unit rate. Basically, if you don't know 12 times something's 456, then you're going to have to use unit rate. And I need you to kind of write this down with me, because it'll sink in after a couple of them, okay? So, okay. Basically, all it is if this is how many share a locker for 12 kids, what they want us to start doing is using the unit rate right here. Meaning, how much is one kid? How much does one student have? Which is what we did last week. Okay? Now, I need you to think about it. How do you get from a 12 to a 1? Divide by 12. Okay. So if you divide by 12 on the bottom, you're going to divide by 12 on top. Now, 1 divided by 12. Handy dandy calculator. 1 divided by 12. Now, you get some crazy decimal number. And I need you to listen. Please just listen for a second, guys. Y'all's 5,000 comments make it where some kids can't concentrate. Okay, so I took the top and I did 1 divided by 12. And yes, I get this weird number. Yes, it is okay. Listen, this is the number. And I'm even going to put the little 3 repeating right there. But here's the key to this. That is the unit rate. We just don't talk about 8/100ths of a person. That's like a finger, okay? So, what we do is this. We now can see that if that very small number is 1, how can I get from a 1 to a 456? Times what? 456, yeah. Y'all know what to do from here. You're just going to multiply times 456. Well, if you're going to do that down here, you're going to do it up there. But here's the key. I hope you're listening. Don't change your calculator. Leave on your calculator that crazy number and just type in times 456. And you get 38. You got the answer. If you will leave the weird number on the calculator, you will get the right answer. It's just sometimes not exactly on that one. Some of you figured out 12 times 38 was 456. But if you didn't get that, you may have to use unit rate. Okay? Yes?
I did mine differently. I just did 456 divided by 12 and got 38.
Yes. And it's the same thing. It is 456 divided by 12. It's hard to explain, but I have to teach the kids how to get 1. But if you see your way, as long as you're getting 38, we're good. Okay? Yes?
Doesn't matter which one you talk about.
Yes, if you're going to use unit rate. Because otherwise you're going to end up dividing wrong. Here we go. On number 3. If 84 cookies will serve 28 students, how many cookies are needed for 30 students? Tomorrow, don't sit there. I've asked you before not to sit back there. I want you to scoot up. Thank you. Here we go. Cookies to students. Okay, because I'm wanting to know how many cookies does each kid get. One kid, not one cookie, one kid. Okay, so in the first sentence, it says 84 cookies for 28 students. So they want to know how many for 30 students. And we can't add. Listen, slow down. Okay, but you just can't. My thing is this. I'm worried some kids do think that they can add 2 to get that. But I keep preaching and telling y'all, please don't add and subtract. We can't jump from 28 to 30 easily. So what could we do? Divide.
What?
By what? Okay, even if we did by 2, I'm going to get 14. Does 14 help you get to 30?
No. Wait, let's do 4.
Okay, if I did 4, I would get 7. Is 7 going to help me get to 30?
Yeah. 6.
6 times 4 is not 30.
Wait, but 6 times 5.
It's 30, not 4. Guys, go back to what I just did at the top. We're going to need to find a unit rate. How much is 1? So how can I get that to equal 1? 28 divided by 28 is 1. 84 divided by 28 is 3, yes. Can I now jump from a 1 to a 30?
Yeah.
Times 30. So 3 times 30 is 90. 90. And it makes sense. Okay. On number 4, they're talking about out of 50 teenagers, 9 said they got their news from the newspaper. Obviously an old textbook. Yes?
On the last one, I think that's what I did before, but it didn't work.
That's because if the students, if you're finding out how much is 1 cookie, it's going to mess up your math. You flipped your numbers. Probably. Okay? So try it the other way and see if you can get it. On the newspaper one, 50 teenagers, 9 said they get their news from the newspaper. We're wanting to know newspaper per student. So per kid. Okay? Now, so I'm going to put, these are the kids who, read the newspaper? Please stop with the 5,000 comments. And the bottom is the total students. So that out of 50 teenagers, 50 is the total. 9 said they get their news from the newspaper. Okay, so what if we had to poll or question 300 kids? What is it? 6, right. Y'all know it because of money. 2 50s make 100, right? So 50 times 6 would give me that. 9 times 6 is 54. So if there were 300 kids, 54 would about get their information from the newspaper. It makes sense as you go across. Okay? You could do unit rate again. You could find how much 1 is. But the numbers are kind of ugly. They're not pretty. Now, your homework tonight is page 183. It's right here. It's in the red textbook, 5 through 13. I have already sent it out on Remind so that some kids could use it at lunch. I had a few kids asking me for questions. here is, start with number 5. This is what it looks like. Going on down, 8, 9, 10. And then 11, 12, 13. Okay. I'm going to leave it up here for you guys in 8th period. You want to start working? I'm going to start working. I'm going to leave it right there so y'all can see it.